Ayan na. Okay, so yan. So balik tayo. So the idea here is that we can use the lone pair to create a bond, no? Kunwari ito, we have this lone pair. Pwede ito maging bond, no? Paano yung movement ng electron? You will just move the lone pair from the atom to this line dito, no? Remember, two electrons ang kailangan to create a bond, no? So that can happen, no? So you can use the lone pair to create a bond. Then what will happen? This oxygen will exceed the octet rule. So in order for it to follow the octet rule, para hindi siya mag-exceed ng octet rule, what will happen is that the adjacent bond to it, no? For example, this bond, siya yung uurong papunta sa atom naman, no? Okay, so what happened is that the lone pair decided to be a bond. So nangyari yon. So naging bond siya. Then since oxygen already violated the octet rule, ang gagawin niyang remedy is for this bond to be a lone pair, no? So itong bond na to, yung dalawang electrons dyan, gagawin niyang lone pair ng oxygen na yan. So what will happen to our molecule is ganito, no? Yung double bond, malilipat siya. Wala na siya sa right side. Nasa left side na siya, no? Okay, so let me do the structure muna. Okay, so ito yung magiging resulting structure, no? So what happened is this, no? We use this lone pair to create a double bond. So we have a double bond here nasa left side, no? And then oxygen pushed this bond para maging lone pair ni oxygen na yan. Okay, so nawala yung double bond dito, naging lone pair siya. Okay, so if that is possible, if the movement of electron can happen from lone pair to bond, bond to lone pair, that means we have a resonance structure. It means these two structures are equivalent, no? So equivalent yung dalawang yan. Ano lang yung difference nila? The location of the lone pairs and the double bonds, no? Okay. So yan. So this is this is a resonance structure, no? So yan, every time you see an electron moving, no? So yan, may resonance structure ka. So paano uli sir yung Paano uli yung technique dito? The technique is ganito, no? You can create a resonance structure by using a lone pair to make a bond, no? Ganun yung first step. You will use lone pair to make a bond. Then the excess bond here sa lumagpas na sa octet, you will use that excess bond sa adjacent bond para maging lone pair ng adjacent atom na. So yan, lone pair to bond, bond to lone pair. If that movement of electron is possible, hence you have a resonance structure. Okay, so ganun lang. Hindi na tayo magdadwell masyado rito because this will be discussed further in organic chemistry now. So at least you have the idea. Ano yung idea? We can use lone pair to make a bond and we can use the bond to make a lone pair. If that is possible, hence you will have a resonance structure. Yun lang. Na. So let's have another example, CO3 carbonate. So the Lewis structure of carbonate is already given last time. So draw ko na lang. Okay, so oxygens, the singly bonded oxygens will have the negative formal charge. No? Okay, so anyway, so let's do the resonance structure for oxygen. So paano yung resonance dyan? So pili ka lang ng may lone pair na single bond. No? For example, I will use this oxygen here. No? Yan. So I will use this oxygen here. No? Itong lone pair niya, I will use that to make a bond. No? So paano yung movement? Lone pair to bond. So I will create a double bond here. Then what can you observe is that the carbon here will exceed the octet rule. So anong gagawin niya? the carbon will push the adjacent double bond, yung isang bond doon, itutulak niya para maging lone pair ni oxygen na. So, our resulting structure would be this one na. Okay, so this will be our resulting structure. What happened again is that the oxygen here, the lone pair of this oxygen was used to create an extra bond, a double bond, no? And as a result, carbon exceeded the octet rule. To resolve that, anong ginawa ni carbon? Carbon pushed this double bond from this atom, no, para maging lone pair niya. Okay. So, ano napansin nyo? Yung double bond, instead na nasa taas, napunta siya sa left side. No? And since possible yung structure na yan, that means these two are resonance structures. No? Ano pa yung isa pang resonance structure dyan? Dito naman ako sa left side. Ano pa yung isa pang resonance structure? No? Kunwari, this oxygen. No? This oxygen, kunwari, gusto niya maging sa kanya naman yung double bond. Eh di sige, pagbigyan. No? So we will use the lone pair to create a bond here. Yan. Then, since carbon will exceed the octet rule, itutulak niya yung electron dito sa bond, no? Papunta sa oxygen na yan, no? Okay, so yun yung idea ng resonance, no? So, nagtutulak-tulak lang sila ng electron. So, oxygen on the right side will now be bonded with one bond lang, no? And then yung oxygen on the right side will have the double bond, no? And again, for example, itong oxygen, gusto niya siya naman uli maging double bond. So yun, that oxygen can use the lone pair to create double bond. Then that will push the double bond of this atom para maging lone pair. Hence, babalik ka dito sa structure na to. No? Okay, so that's the idea of resonance. Ano uli yung idea of resonance? We can use the lone pair to create extra bonds, no? And we can use the bonds to create lone pairs, no? So if the movement of the electrons, no, in that fashion is possible, that means you have resonance structures, no? The electrons resonate, no? When you say resonate, the electrons are moving around the atoms of your molecules, no? So, hindi sila different, no? Pero they are equivalent lang, no? So, ito, same dito, dito same yan dyan, no? So, yan, no? Para siyang fidget spinner na pinaikot mo, no? So, yan, iba-iba yung location ng double bond, no? Okay. And that is observed, no? Malalaman nyo in organic chemistry soon, next by the final period, malalaman nyo that the resonance structure can actually help you to memorize some organic reactions, no? Basta yan lang yung idea ng resonance. Paano yung movement ng electron? Let's summarize this part, no? The movement of electron in your resonance is lone pair to bond, then bond to lone pair, no? So that's the idea. Lone pair to bond, bond to lone pair. Lone pair to bond, bond to lone pair. Okay. So dapat yung adjacent atoms yung gumagawa nun, no? The adjacent atoms will push the electrons, no? Para makagawa ng ganitong sequence. Lone pair to bond, bond to lone pair. Okay. So that's basically the resonance structure, no? So we will discuss this further in organic chemistry, no? Kasi resonance structures are proven to be stable for organic chemistry, organic molecules, no? Okay, so we're done with resonance structure. Now we will revisit the octet rule, no? I mean the NASU rule, no? Okay, so ano yung mga napapansin nyo with the NASU rule, no? So, limited yung NASU rule in such way that yung A, as much as possible, dapat even number yun, di ba? Hindi ko sinagot yung question last time na, sir, paano kapag add to? Kunwari, 11 yan. Ba't di ko sinagot? Ngayon kasi natin siya sasagutin, no? So, yan. So, in cases that your NASA rule, no, fails to follow the norm, when I say that, no, meaning ko doon is may odd numbers, no, kulang yung bonds, o kaya sobra ng bonds, no. So, if our NASA rule, no, parang hindi siya nagsasatisfy sa conditions natin, that means we have violations of the Octet rule, no. Okay, so ano po ba yung mga violations ng Octet rule? Or exceptions to the Octet rule, no? There are molecules that violate the Octet rule, no? Bakit sila nagva-violate, no? Kasi gusto nila, no? So, yan, trip nila. Paano nila naging trip, no? So, tatlo yung cases natin. Let's isa-isahin natin to. So, may molecules na mag-violate ng octet rule kasi trip nila maging incomplete octet, no? Hindi naman sa trip nila, no? No choice lang sila kundi maging incomplete octet, no? So, when you say incomplete octet, hindi kailangan ng 8 electrons around the atom, no? So, pwedeng 6, pwedeng 4, no? Pwedeng 2, no? So, ano yung reason why they have the incomplete octet, no? So, the first reason would be, number 1, ano yung first reason natin? It only contains the s orbital. Okay. Remember, ilang electrons kaya ng s orbital? 2, di ba? Yun lang, hindi siya kaya magwalo. So, one example of the incomplete octet would be hydrogen, yung ginagawa natin last time. So, hydrogen cannot accept more than 2 electrons because it only contains an s orbital. No? S orbital lang meron siya, first energy level lang siya. So, wag ipilit na pag hindi kaya. So, that means hydrogen will have an incomplete octet. No? S orbital lang yung kaya niya punuin. The second reason why atoms sometimes have incomplete octet is because it has a metallic property. For example, let's look here. We have boron. Diba sabi ko last time, pag nasa p orbital, it should follow the octet rule, diba? Should, no? Ibig sabihin nun, pwede may pasaway, no? Okay, so let's look, no? So boron is here, no? Ayan. Boron is found on the p orbital. Yes po. Wala namang magagalit dyan, no? Nasa p orbital naman talaga siya. Aluminum as well, nasa p orbital din siya. Okay. Pero let's classify the atoms, no? Kung metal ba siya or non-metal. Okay. Kung mapapansin nyo, boron is a semi-metal. So, meaning nun, it contains properties of both non-metal and metal, no? So, kumbaga, balimbing siya, no? Okay. So, ganun yung mga silicon, germanium, no? So on and so forth, no? So, metalloids, no? So, yan. Ano pa yung mga metals na nasa p orbital? One example would be aluminum, gallium, something. So, ano yung tendency ng metals? No? Why would they violate the octet rule? Ito yung tendency nila. Remember, your metals love to give off electrons. No? Gusto nila magpamigay ng electrons. So, they should not accept electrons at all. No? So, ano meaning nun? So, ibig sabihin nun, they really don't like to follow the octet rule for the reason that they don't like electrons that much. No? Hindi nila gusto masyado yung electron. Pwede silang mag-form ng bonds, yes. Pero, hindi nila ganun ka-trip yun. No? So, kasi gusto nila mamigay eh. Parang, sige, okay, tanggapin ko, pero ayaw ko talaga. No? Parang yun yung ganap ng mga atoms in the p orbital na metals. No? So, yan. So, if your atom has a metallic property, then you should observe that you cannot form the octet rule. No? You cannot follow the octet rule for such cases. No? So, anong mga examples natin doon? No? For example, we have beryllium. No? Beryllium is in the second row. No? That means it contains S and P orbitals. Pero, ayan, ilang electrons lang kaya niya i-accommodate? 4. No? So, 4 lang. So, violation ng octet rule yun. Yes, pero no choice siya. Wala tayong magagawa. Ganun talaga. Let's have another example. BF3. No? So, itong BF3, tignan natin. The boron only contains 6 electrons around it. No? Di ba nasa p orbital yan? Yes. No? Pero again, boron possesses metallic property. No? So, okay lang kahit less than 8 yan. Kasi medyo metal yan eh. Okay? So again, sino yung mga atoms that violate the octet rule na incomplete yung octet? Lista natin para pag nakita nyo, may intuition na kayo kung sino yung may violate ng octet rule. So the usual atoms that will violate the octet rule would be hydrogen, beryllium, magnesium, boron, aluminum. Yan lang naman. Yan lang yung mga typical example. Okay, so boron and aluminum, these atoms are found in a p orbital. Yes. Pero, again, they have metallic property. So, they really don't like accepting electrons. No? So, ayaw nila masyado ng electron. So, okay lang sila mag-violate ng octet rule. Okay. So, bibigyan ko kayo ng proof. Kunwari, we have si BH3. No? Kunwari, nakalimutan nyo yung technique natin. Diba? Ang idea is that yung boron, it will not follow the octet rule. Meaning nun, NASU rule, hindi natin magagamit yung NASU rule dito sa case na to. Kunwari, nakalimutan nyo yung ganun, no? Tapos nag-NASU rule pa rin kayo. Try natin ipakita that NASU rule will not be followed for this structure. Hindi niya susundin yung NASU rule. Ayan. Diligay ka pa. Okay, so gawin natin yung NASU rule dito for BH3, si B. So for boron, since it is in the p orbital, ano yung idea ulit? Dapat kapag p orbital, dapat di ba mag-octet? No? So sige, tanggapin na lang muna natin ngayon. Okay, so kunwari octet siya. No? Si hydrogen wala tayong choice, dalawa lang yan eh. Okay, so 8 plus 6, 14 na. Okay. Available, boron is in the third period, so 3 electrons yan. I mean, third group, no? So, 3 yung valence electrons niya. Hydrogen is in the first group, so 1 valence electrons. 6. So, 14 minus 6 is 8 or 4 bonds. Tapos, yan. So, yan. Tignan nyo. Nagkakagulo na yung nasa rule natin. 6 minus 8 equals negative 2. Hala, may negative na lone pair. Diba? So, mapapansin nyo, when you do the NASO rule for this molecule, na alam natin na mag-violate ng octet rule, tignan nyo, magkakagulo yan. No? You will have a negative lone pair. No? Magkaka-negative lone pair ka. Imposible yun. No? Tapos, tignan nyo, you have 4 bonds. No? Let's draw the skeleton muna. Okay. So if I am going to connect my terminal atoms to the boron, dapat single bond lang. Kasi hydrogen lang yan eh. It is only capable of accepting 2 electrons. Kung mapapansin nyo, may sobra akong isang bond. Tapos may negative na lone pair pa. So that means, our NASA rule will not work for this molecule, no? Asaan? Question mark. Nasaan yung, ano ba yan? Saan mapupunta yung extra? Saan yung extra? I don't know. Extra. Bakit may negative na? Okay, so ano yun? Ito lang yung proof that this molecule will not follow the NASO rule talaga. No? Kasi tignan nyo, so, sobra-sobra yung bond, mas may negative na lone pair pa. So that means this molecule will really violate the octet rule. No? So ano yung technique ko dito? Bibigyan ko na kayo ng technique ko para mas mabilis ang buhay. Whenever you see these 5 atoms, yung hydrogen kahit di na pala, no? Matic na yan eh. No? Kasi that can bond with atoms na pwede mag-octet. No? Pero anyway, if makakita kayo ng combination ng molecules wherein your central atom would be these atoms, no? Kung ito yung mga central atoms mo, wag na kayo mag-NASO rule. Do not use NASO rule. Okay. So, pag nakakita kayo ng molecules wherein these are your central atoms, do not use the NASO rule kasi tignan nyo, no, madidisappoint lang kayo. No? Sobra yung bond, may negative na lone pair. Ano yon? Wala. No? So, ano yung pwedeng gawing remedy dyan? No? So, asan yung isang bond? No? Question mark. Asan yung negative lone pair? Hindi mo rin alam na. Okay, so yan. So, NASO rule, hindi ka matutulungan yan for this first violation, the incomplete octet. So, sir, paano ko i-drawing yan? Ganito lang. Go back to the basics, no? Yung basic tayo. Paano yon? You will draw the Lewis dot symbols instead, no? So, paano tayo magdodraw ng Lewis dot symbols, no? Of course, you have to identify your atom muna, no? Sino yung mga atoms natin? Boron, hydrogen, hydrogen, hydrogen. Then you draw their valence electrons using dots, no? Ito yung ginawa, I don't know if nakapag-lecture na kayo, no? Pero si lecture magdi-discuss ng Lewis dot symbol. But anyway, so, yan. So, hydrogen is in group 1. So, I will represent that as 1 dot, 1 dot, 1 dot, no? So, yan. Si boron naman, this is in group 3. So, 1 dot, 1 dot, 1 dot, no? Then, ano gagawin ka? I will just connect the dots, no? Ganun lang siya kasimple. Ito yung ginagawa nyo dati nung junior high, no? So, babalikan nyo na lang siya uli kapag violation na siya ng octet rule. Okay? So, since we cannot use the NASO rule here, then balik tayo sa basics, Lewis dot symbols. Okay? So, as you can see, na-connect naman natin lahat ng atoms, no? Okay. And wala tayong negative lone pair. So, this is an acceptable structure, no? So, that means the molecule for BH3 would really look like this, no? Ayan. So, ganyan talaga yung structure niya. Yes, boron will have 6 electrons around it, no? Hindi siya mag-octet. Wala tayong choice because, again, boron have a metallic property, no? Metallic yung kanyang property. So, no choice kundi maging less than 8 talaga. And that's okay. That's fine. Okay? Another example would be this molecule. Aluminum, hindi. Mamaya na yan. Aluminum trifluoride. Wait lang. Charge. Okay. So another example would be AlF3. Okay, so looking at the atom, aluminum will be my central atom. F will always be the terminal, di ba? Again, tignan nyo. Metal yung aluminum. So you should expect that it will violate the octet rule. Magna-NASO rule ka ba? Wag na. No? Pero kunwari, gusto ko ulit. No? Gusto ko lang patunayan na mali ako. No? Minsan kasi maganda yung ganun. No? Patunayan mo na mali ka. Okay, so magna-NASO rule ako. Trip ko lang. Alam ko naman mali ako pero gagawin ko pa rin, di ba? May mga makaka-relate doon, di ba? So again, so aluminum, you can see that in the p orbital. So let's say kunwari 8 yan. Kunwari lang na 8. Fluorine 8 talaga yan. Wala tayong choice dyan eh. 8, 16, 24, 32. Tapos valence electrons, aluminum would be 3. Fluorine would be 7. 7, 14, 21, and 23, 24. Then 32 minus 24 cannot be. No? 6, 7, 8. 8 na. Okay, then so yan. So ang unshared natin, di siya negative, no? Pero sige, 24 minus 8, 16 or 8 lone pairs. So, yan. So mukhang okay naman, di ba? Okay, mukhang okay. Pero the problem here is kapag nag-draw ka na ng structure. Again, as you can notice, fluorine will always form single bonds, no? Single bonds lang yung ginagawa niya madalas. Okay, so we have 4 bonds to deal with, no? 4 yung bonds na kailangan natin ilagay. Pero again, yung fluorine, tigi-isa lang yung kaya nila. Paano yung sobrang isa? Nasaan yung extra electron? Nasaan yung extra bond, no? Hindi natin alam kung saan natin siya i-connect. Again, fluorine cannot form double bonds, no? Single bond lang yan. So, yun yung problem, no? So, again, na-disappoint ulit tayo. Pero expected naman, no? So, yun. When you do the NASU rule, we saw na may extra bonds tayo. And hindi natin siya malagay sa structure. So, that means this is a violation of the octet rule. Kaya nga sabi ko, tignan nyo na lang yung central atom. If that atom has a metallic property, then wag na kayo mag-NASU rule. Sayang yung effort. So, ano yung remedy? Remedy would be the Lewis dot symbols na lang. So, ito yung kasagutan sa ating problema. So, you draw the Lewis dot symbol for your elements. Aluminum would have 3 valence electron because it is in the third group. Fluorine would have 7 dots, no? Or 7 valence electrons. Ayan. Okay, so connect ko na lang. Ganun na lang. Connect ko na lang. Okay, so tapos na. Okay, so I'm done. So my final structure would be Al. Then we will have single bonds here. Okay, so that would be my final structure, no? No more extra bond, no? So yan, hindi na ako sasabihan ng nasa rule, oy, may isa pa. Wala na. So ganyan lang kasimple yung remedy for the incomplete octet, na. So you just draw the Lewis dot symbols, then you're done, no? Tapos na. Okay. So yan, so that's the first violation of the octet rule, the incomplete octet. Again, let's go back. Bakit incomplete yung octet? Number 1, s orbital lang yung kaya. Again, s orbital can only hold 2 electrons. S orbital lang meron. Okay, so yun, 2 electrons lang yan pag ganyan. Number 2, if nakita mo siya sa p orbital, then may metallic property siya. It will violate the octet rule, no? Magiging incomplete octet yan, no? Such as boron and aluminum, no? So these two, they have metallic properties, no? So mag-violate talaga yan, no? Wala tayong magagawa doon. Okay? So that's the first violation ng octet rule. Ano yung remedy? Remedy. Ano yung lunas para masagutan yung problem, no? Is for you to draw the Lewis dot symbols na lang. Mag-draw ka ng Lewis dot symbols, then you connect the dots, no? The single dots. Ayan. Ayan, ginagawa niyo yan since bata pa, di ba? Ayan, dapat master niyo na yan, no? Nung nung mga 2 years old pa lang kayo, di ba? May mga dots kayong dinudugtong. O, ito na siya ngayon, no? Dots, di ba? Level up, di ba? So, yun. So, yun. So, basta i-connect nyo na yung mga single dots, no? So, ganun. Tapos na yan. Okay. So, we're done with the first violation. Let's proceed with the next violation. The odd electron molecules. Ito yung sinasabi ko na, paano kapag odd yung available electron sa NASU rule? Now, we can use the NASU rule dito. Yan. So, pwede ka gumamit ng NASU rule dyan. No? Ito yung question dito. Sir, paano kapag add yung available? Paano kapag add yung shared electrons? Ano gagawin ko? No? Dali lang. No? So, okay, punta muna tayo sa concept ng odd electrons. No? So, the reason why we have odd electrons kasi is because we have radicals. No? So, what are radicals? No? Radicals are single electrons. No? Hindi siya paired. Anong tawag natin kapag paired? Lone pair. Diba? Paano kapag one dot lang yan? Yan ay radical. No? Okay, so radical kapag hindi siya paired electron. Lone electron siya, pero hindi paired, no? Okay, so meaning ng lone, hindi ginagamit sa bonding. No? Okay. So yan, itong lone pair di talaga ginagamit sa bonding yan, pero itong radical na to, hindi yan ginagamit sa bonding, no? Pero, unstable yan, no? When you say unstable, it is highly reactive, no? So, pwede siya magwala, no? So, yun yung idea. That's why, may nakikita ko yung mga food supplement na sabi nila, radical scavengers, no? Sa katawan, no? And hindi yung marketing stuff, no? Totoo yun, no? Our body can sometimes have these radicals, no? And again, sabi ko nga, these radicals are highly reactive, no? If you have radicals in your body, that can actually cause diseases, no? Such as cancer. Cancer agad, no? Okay, so, ano yung remedy doon? Number one, kumain kayo ng gulay, no? So, our gulay, no? Mga gulay-gulay, mga halaman, they have radical scavengers, no? Meaning nun, sila yung mga pumapatay ng radical sa katawan, no? So, yung mga, let's say, mga beta-carotene, no? Sa beta-carotene sa carrots, no? Yung conjugation ng electrons doon. Ang itsura kasi ng beta-carotene is ganito may paganyan-ganyan, tapos may double bond, no? So, the radical can actually be suppressed by these double bonds, no? Sa beta-carotene. Although, malalaman yan pag nag-ano na kayo, pag nag-biochemistry. Share ko lang. Okay. So, yung radicals, they are dangerous, no? This can cause cancer, no? At kung worse na, magiging cause yan ng cancer. Okay. So, toxic yan. Pero nag-e-exist yan. For example, sa polluted air ng Manila, no, may traces of nitric oxide and nitrogen dioxide. No? So, may traces ng ganitong molecules. No? Saan sila nakikita, sir? Sa exhaust ng sasakyan. Okay, so sometimes kasi yung sasakyan natin, nagre-release sila ng NO2 pati NO gases, no. That's why people living in polluted areas, no, they tend to be sickly, no. Masakitin sila kasi yun, no, medyo maraming radical kasi yung mga nilalanghap nila, no. So then again, if may radicals sa katawan ng tao, that can cause disease, no. And worst case na yung cancer, no. Ano pa yung reason bakit nagfo-form ng radicals, no? One reason is the exposure to UV rays, no? The sunlight, no? Too much exposure sa sunlight, no? The UV rays can actually form radicals, no? Pwede niya itulak yung electron ng lone pair. Kunwari, ito yung UV ray, no? Ito yung UV ray. Tinulak niya yan. So, tumalsik yung isang electron sa lone pair. Possible yan. So, what will happen is that if the UV ray, no, pag yung UV, it is able to kick off one electron sa iyong lone pair, magkakaroon ka ng radical. That's why prolonged exposure to sunlight can cause cancer because of these radicals again. This radical can react with your DNA, and as it reacts with your DNA, what will happen? Your DNA will be destroyed. Then destroyed DNA means cancer, no? Mutation in your genes, no? Cancer 'yon. So yun yung consequence ng pagkakaroon ng radicals. So again, paano mawawala yung radicals? Yung mga food supplement, Hindi naman ako magbebenta, no? Sinasabi ko lang kasi nabentahan ako eh dati. So, yan. So, totoo naman, no? May chemistry, ano naman doon, may chemistry explanation. So, again, to remove radicals in your body, you eat, you eat gulay, no? So, maraming gulay kailangan. Kaya siya kailangan sa diet, no? Yan, because they help remove the radicals, no? Even in our body, we can naturally form radicals, no? Yung ating fats, no? Pwede yung mag-form ng radicals, no? Pag na-oxidize yung lipids, yun, pwede magka-radicals dyan, no? So, yun, kailangan healthy living tayo and avoid polluted areas, no? If hindi kaya mag-avoid, hindi mag-face mask, no? So, face mask can actually filter gases, no? So, yun. Hindi lang coronavirus. Pwede rin siya makatulong to lessen your exposure to radicals, no? Yan. So, be careful, na? And kumain ng gulay, na? Okay. So, again, so balik tayo. Balik tayo sa chemistry. Ay, chemistry rin naman yung pinag-usapan natin kanina. Balik tayo sa drawing, no? Okay, so whenever we have odd electrons in our available and shared electrons, that means we have radicals, okay? So we have to take into account na may isang radical doon, no? Yun yung reason bakit odd yung number niya. And we can use Naso rule. Sir, kailan namin malalaman kapag yung molecule ay may radical? Tignan nyo yung examples natin. Ano yung common atom sa kanila? Yung nitrogen, no? Because yung mga molecules with nitrogen, no? Yun yung mga usually containing. Yun yung mga usually nagfo-form ng radicals, no? So, yun, ganun, no? So, pag nitrogen containing yung atom mo, tapos naging odd number yung electrons mo, tanggapin mo na yung fact na may radical doon, no? So, okay lang yan. So, let's have examples. By the way, dalawa lang naman yung common example niyan. Ayan na yung structure niya. Pero, draw natin, no? Wala rin din natin alam itsura. NO pati NO2. Ito lang yung examples ko dito madalas, no? Bibigay ko na para alam niyo na yung sagot, no? Okay, so let's draw the Lewis structure for NO. Again, pag may nitrogen, we can use the Naso rule, no? Wala namang metallic property diyang mga atoms na yan, no? So, pwede tayong mag-Naso. Naso. Nitrogen, oxygen. Okay, so for nitrogen, it will follow the octet rule dapat, no? Oxygen, mag-octet rule talaga yan. So, this is 16. Available. Nitrogen is 5. Oxygen is 6. 11. Uy, add, no? Wala namang charge para mabawasan yon. So, no choice tayo. Add talaga yan, no? Okay. 16 minus 11. 5. Wala. So, 11 minus 5. 6. Or 3 lone pairs, no? Okay, so, yan. We have no charge, so hindi natin pwede gawing even to, no? So wala tayong choice kundi tanggapin ang katotohanan that this number is even. That means the shared electrons is also, odd pala. This number is odd, that means the shared electrons is also odd number. So ano gagawin nating remedy dyan, no? So tuloy mo lang yung Naso. And just continue doing the Naso rule, no? We will still get even number for the unpaired electrons naman, na. So okay yan. So, ano po gagawin namin sa 5? Pag dinivide ko po kasi yan sa 2, ang magiging sagot ay 2.5. Paano ko po i-draw yung 2.5 bonds? Okay, ganito yung sagot. Okay. So, for you to address the issue na add yung shared electrons mo, split mo lang yan into 2. Yung isa dyan would be your radical, meaning single dot lang yan. Then yung matitira, ito yung electrons na gagamitin sa bonding. No? Ayan yung magiging bonds na. So, ano ulit yung tip? No? Pag add talaga yan, add yung iyong shared electrons, you subtract 1 electron. That 1 electron will be your radical. Okay? Paano yung natira? Yun yung gagamitin mo sa bonding. No? Usually, even number talaga yung matitira, diba? Okay? So, ganun yung remedy. Pag may nitrogen, odd number yung shared, mag-minus 1 ka, no? That 1 corresponds to your radical. The remaining electrons will be used to form bonds. No? Okay, so paano natin yan ito drawing? No? So this is our NO. We have 2 bonds. Lagay natin yan, 2 bonds. Then, yung radical sa dulo ko na yan ilalagay. No? Ano yung ilalagay ko muna? Bonds and lone pairs. No? So I will place my lone pairs, tatlong lone pairs. Kanino muna? Sa terminal kay oxygen. No? So oxygen here, it already contains 4 electrons. So kailangan niya pa ng dalawang lone pair. Okay. So octet na yan. Sa nitrogen, sa kanya yung isa. No? Sa kanya yung tira-tira. So I have 3 lone pairs already distributed in my molecule. Then I'm left with the radical. No? Saan natin nilalagay yung radical? Kay nitrogen. No? 1 dot lang yan. Ayan. So yan. That's the structure. Tapos na yan. Sir, magiging octet po ba yan? Again, hindi. No? Look na. Kaya nga violation siya ng octet rule. Tignan nyo. How many electrons are there around nitrogen? 1, 2, 3, 4, 5. Ay, hindi. Sakto lang pala. Yung formal charge pala niya, tama na. Pero tignan nyo yung octet rule. Tignan yung octet na. We have 2, 4, 6, 7. 7 electrons lang nasa paligid niya. Wala tayong choice. Wala na tayong magagawa dyan. Ganyan talaga eh. No? Pero yun nga, looking at the formal charge, wala namang charge to. 5 electrons na sa paligid niya. It should have 5 electrons as well. So 5 minus 5 is 0. Ito, 6 electrons na sa paligid niya. So formal charge niya is 0. So nag-agree yung formal charge, 0, 0. So, pero yung octet rule, kulang kay nitrogen. That's okay. No? Okay lang yan. Kasi sabi nga natin, that's a violation of the octet rule. No? So yan. So if you see a molecule with nitrogen, just do the NASO rule. Pag naging odd yan, that means one of that electron is a radical. No? Radical yan. So saan mo ilalagay yung radical? Sa nitrogen. Kailan mo siya ilalagay? After placing the bond and the lone pairs. So lagay mo muna yung bond, lagay mo muna yung lone pairs, then saka mo ilagay yung radical kay nitrogen. Okay? So that's the structure. No? Okay, so let's proceed with another structure, NO2. So for NO2, we can use the NASO rule again. Again, nitrogen, as much as possible, dapat 8. Oxygen, 8 talaga yan. So 8, 16, 24. No? So 24. Available, nitrogen is 5. Oxygen is 6. 12 plus 5, 17. No? Pahirap ng pahirap yung subtraction natin dito. 24 minus 17, 7. No? Wala, 7. And then 17 minus 7 is equals to 10 or 5 lone pairs. Again, ano meaning? Kapag odd number yung shared electrons, you split that into 2. Yung isa, radical. Yung 6, yun yung gagamitin mo to create 3 bonds na. Okay? So, ganun lang ka-simple yung sagot na. Okay? So, that's the idea. Then, we can draw the structure for NO2. The central atom would be nitrogen. Oh, no. Ayan yung kanyang structure, no? Oh, no. Okay. Then, ano gagawin natin? We will place the 3 bonds, no? To connect the terminal to the central atom. 1. Okay. So, ganyan. So, these are my 3 bonds, no? Then, ano yung susunod ko? Lone pairs. So, I will start with this terminal oxygen. So, ilan yan? It already contains 4 electrons around it. So, 2 lone pairs na lang. So, this is already octet now, yung oxygen octet na yan. So, looking at this oxygen, I have 2 electrons. It requires 6 more. So, that means 3 lone pairs. Okay. So, na-distribute ko na lahat ng lone pair. 1, 2, 3, 4, 5. So, radical na lang. So, saan uli nilalagay yung radical? Sa nitrogen. Okay. So, again, as you can see, nitrogen here will not have an octet. 2, 4, 6, 7. 7 lang. Pero okay lang yan. Wala na tayong issue dyan masyado. Nag-exist yung molecule na yan. No? So yan, so that means the only possible structure for NO2 is this one now. And just accept the fact that nitrogen will never follow the octet rule, no, because of the radical. No? And that's okay because that molecule exists, no, and it kills, no, nakakapatay yan. So yan. Yan lang naman yung typical structures na meron tayo na may radical, no. So again, so let's go back, no? So dalawa na yung na-discuss natin na violations. The first violation is the incomplete octet. The incomplete octet, no? Bakit? S orbital lang meron. It can only accommodate 2 electrons. Metallic property yung atom. So that really don't like electrons, no? Ayaw niya masyado ng electrons. So less than octet siya. So ano yung remedy doon? Lewis dot symbols. Connect the single dots, no? For odd electrons, you still use the NASA rule. Pag nakakita ka ng molecule na may nitrogen, baka mag-follow yun dito, no? So, ayan. So, gamit ka pa rin ng NASA rule. Pag nakita mo na odd yung kanyang electrons, such as in our cases, ito, odd yung shared electrons. Meaning nun, one of the electrons there will form the radical, no? The other will be used to create bonds, no? So, you can still draw the structure. No? But again, nitrogen will never follow the octet. No? In such cases, kapag may radical. Okay? Last one, expanded octet. No? So, ano yung expanded octet? No? So, ang basis kasi for octet is that the s and the p orbital has to be filled, no, in order for your atom to be a noble gas configuration. So, kailangan ang S ay puno ng 2 electrons, ang p orbital ay puno ng 6 electrons. So if you add 2 and 6, 8, 'di ba? Kaya octet, no? Okay. Yan yung reason bakit octet. So dalawa sa S, 6 sa p. So pag pinag-add mo yan, 8, octet. And usually atoms that contains complete S and p orbitals, they exhibit noble gas configuration with exception to helium. Helium kasi is S2 lang. So, wala na tayong magagawa, no? Ganun siya. Okay, so, yun. Paano magkakaroon ng expanded octet? Kailan lalagpas sa octet? If you have d orbital, no? So, if your molecule, your atom, the central atom, sulat ko dito. If your central atom contains d or f orbital, that means it can follow the expanded octet, no? So, pwede siyang lumagpas dyan, no? So, ganun. So, sir, paano namin malalaman kapag may d and f orbital na yan? No? Just look at your periodic table. Again, at the second energy level, ano yung orbitals? Kapag second energy level, s and p orbital lang meron. Pero starting with the third, fourth, fifth, sixth, seventh energy level, you have S, P, D, and F orbitals na. No? So, sa third energy level, may D orbital na yan. Sa fourth energy level, may F orbital na yan. So, that means any atoms from the third period below, such as yung phosphorus, yung sulfur, itong mga to, these atoms can have expanded octet. No? Ano yung reason? Because they have d orbitals na, no? So may d orbitals sila, so that means they can accommodate more than 8 electrons. Because again, d orbital can hold up to 10 electrons, 'di ba? Okay, so yun yung reason. Kaya lumagpas ng 8. Pwedeng 10, pwedeng 12, no? Depende sa trip ng molecule. Okay, so yun. If you have a central atom na makikita mo from the third period pababa, then baka mag-expanded octet ka. No? Baka. No? So, ano yung gagawin mo dito? So, ang technique dito is ganito. Mag-nasurul ka, pero madi-disappoint ka. Okay lang yan. Kasi sometimes there are molecules whose central atom is, let's say, sulfur. Again, nasa third period si sulfur, no? May molecules kasi na si sulfur yung central atom pero it follows the octet, no? Tapos, meron din namang atoms na si sulfur yung central atom pero lagpas siya sa octet, no? Ganun din, si phosphorus, for example. Pwede siya mag-follow ng octet, pwede ring hindi. So, ano yung remedyo dyan, sir, no? Walang remedyo. Magnaso rule ka pa rin, no? Magnaso ka. Pag nagnaso ka, then, kunwari, nag-fail yan, then may technique akong ipapakita, no? So, yun yung work plan natin. Pag hindi gumana si Nasu, may technique akong ituturo. Okay? So, why I want you to do the Nasu pa rin, no? Just to confirm na expanded octet nga yan, no? Kasi pag gumana naman yung Nasu rule, edi hindi siya expanded octet, ha? So, yun. Binibigyan ko lang kayo ng idea na hindi lahat ng may d orbitals ay violation sa octet rule, no? Yung ilan lang, no? Okay. So, anong work plan natin? Ito yung scheme. You do the Nasu rule first. If pumalya yung Nasu rule, then I will show you the technique, no, to answer the expanded octet, no, to draw the expanded octet. So let's have some examples. SF6, sulfur hexafluoride. Ayan, no? So, tignan natin. Tignan lang natin. Sulfur is the central atom. And sulfur can be found on the third energy level, no? Nasa third energy level na siya, period 3. So, dapat may idea tayo, this may violate the octet rule. May. Pwede rin hindi. No? So, ano gagawin natin? We do the Nasu rule muna. No? Nasu. Okay. So, let's assume that sulfur will follow the octet. No? Assume muna natin. Baka kasi gumana. No? So, this is 8 times 1. 8 times 6. Ang daming numbers. 48 yan, diba? 8 times 6. Magiging 8 times 7 yan. So, ganun nyo yung kamay nyo. Ay, hindi pala 48. Diba? Ayoko na nga. Kakalik ko na. 56 pala. 56 nga. Okay, so 56 yung needed electrons. Available electrons for sulfur, that's 6 kasi group 6 siya. For fluorine, that's 7 times 6. Gamit na lang ako ng calcu. 7 times 6 plus 6. Ito yung 48 pala. 48 and then 56 minus 48. Edi 8, no? Or 4 bonds. Stop ka dyan. Mag-isip ka muna. Tingnan niya. 4 bonds lang yung kaya i-allocate ng Nasu rule. Okay, so gawa muna tayo ng skeleton. So sulfur in the middle, fluorine will surround the sulfur. So kung 4 bonds lang yung pwede, meaning niyan, hindi lahat ng atom makaka-connecta. Paano to? Malulungkot yan. No? So, pumalya yung Nasu rule natin. So, epic fail. No? So, fail yung ating Nasu fail. Failed si Nasu. No? So, bagsak. No? Ano pwede natin gawin? Yung technique. No? So, paano yung technique natin? Okay, so I'll show you the technique. Number 1, count yung valence electrons. No? Count mo muna yung valence electrons in total. Include the charge. No? Include charges. Kung meron. Then, what I mean by include charges, kapag negative charge yan, magdagdag ka ng electrons. Pag positive charge yan, magbabawas ka ng electrons. Diba? Okay. So, number 2, ano yung technique? No? Connect terminal atoms using single bonds. No? So you connect mo yung terminal atoms to your central atom using single bonds. Then number 3, deduct used electrons from number 1. Again, when you connect the terminal atoms to the central atoms, you use electrons, di ba? Two electrons per bond. So, pag kunwari gumamit ka ng 5 bonds, no, edi you subtract 10 electrons from your valence electrons. So, magbabawas ka ng 10 electrons, no. Then, number 4, remaining electrons will be used as lone pairs, no. So, ito yung technique, no? Count the valence electrons, connect the terminal to the central using single bonds. You deduct used electrons dito sa 1. Then, yung matira doon, it would be the lone pair. So, kasi palyado yung nasa rule natin, no? And okay lang yan, no? So, wala tayong choice. SF6. Balik tayo. SF6 na. So, sagutin natin yan. Sabi dyan, we count the valence electron. So, bilangin natin. So, the valence electron for sulfur is 6 plus for fluorine, that's 7 times 6. Again, ilan yon? 48 na. Okay, so yun yung first technique, no? You count the valence electrons, 48. Then, anong gagawin? I-connect natin yung terminal sa central atom. So, gawa muna tayo ng skeleton. And then, anong gagawin? I will connect my terminal to my central using single bonds, no? So, ngayon, ilan yung nagamit ko? I used up how many electrons? 10. So, 10 electrons yung nagamit ko. Ay, hindi pala 10, 12. 2, 4, 6, 8, 10, 12. So, 12 electrons yung nagamit ko. So, minus 12. 48 minus 12 cannot be 36 na. So, 36 electrons. Ano yung sabi natin? I can use this to create lone pairs. Ilang lone pairs magagawa ko dyan? 20? Ay, anong 28? 18 lone pairs. Okay, so yan. So, ganito yung technique, ha? You count the valence electrons. Then, you connect your terminal atoms to your central atom using single bonds. So, ganyan. Then, you subtract the used electrons sa valence electrons. So, matitira ka, 36. Then, you will use all of them as lone pairs na. So, when distributing lone pairs again, you start with the terminal before the central, di ba? Okay, so let's look at this fluorine. This fluorine, no, parang yung katulad ng ibang fluorine din, may 2 electrons na siya around it, no? So, it requires 6 more or 3 lone pairs na. So, ayan. So, 3 lone pairs. Then, lahat naman ng fluorine atoms dyan, ganun din, no? So, lalagay ko muna yung mga lone pairs. Again, terminal atoms will follow the octet, no? As much as possible. Yung central, yun yung pwedeng hindi mag-follow. Mga pasaway yan, eh. Okay, so yan. So, I distributed my 18 lone pairs to my terminal atom. So, nothing left for the central atom na. So, 3, 6, 9, 12, 15, 18 na. So, yan. So, that's the structure for SF6 na. So, yan na yan. Tapos na yan na. So, again, paano yung technique na? So, gawa ka muna ng NASA rule. If your NASA rule fails, no? Meaning noon may hindi ka na-connect ng atoms, kulang yung bonds, no? So, punta ka sa technique, no? Pag palyado yan, you go sa technique. Count the valence electrons. I think count valence electrons. Then, you connect your terminal to your central using single bonds. Bilangin mo yung ilan na gamit. You deduct it from your valence electrons. Then, the remaining will be used as lone pairs. So, yan. Tapos ka na. Okay na yan, no? Okay, so let's have another example. XCF4. Ito, last example na to. No? Marami pa naman tayo mamaya. Okay, so XEF4. Sir, di ba yung xenon noble gas? Yes po. Bakit siya bonded with fluorine? Yes po. Yes. Bakit na? Kasi look na. Sa lahat ng noble gas, only xenon has an electronegativity. No? Kasi kapag walang electronegativity, itong iba, meaning nun, hindi na sila reactive. But xenon here is reactive. No? So, ano meaning nun? Yung xenon natin ay reactive siya. Pwede siya mag-form ng molecules. Bakit po? One answer would be the atomic radius. No? Kasi titignan nyo, malaki na yung atomic radius ng xenon because of many electrons around it. No? Marami na kasi siyang electrons. The problem with that is that yung electrons on the outer shell, nasa outer energy level, hindi na niya mahila, hindi na niya mag-grasp. No? So what will happen? The electrons on the outer shell are prone to chemical reactions. No? Unlike the other electrons here. No? So ito kasi mga electrons yan, malapit sila sa nucleus. So sturdy, no? Stable. No? Pero yung xenon masyado na siya malaki. Kaya hindi na niya makontrol yung nasa labas. No? So no choice, it will form bonds. No? And this exists. No? Okay, so yun yung reason. Okay, so again, so xenon, violation yan. Bakit may noble gas? No? Tignan natin kung may violation ng octet rule tayo. So again, paano gagawin? NASU rule muna. No? Okay lang, mag-NASU. Pag pumalya, we have a backup naman. No? Okay, so xenon, ilan yung needed? Siyempre, octet yan kasi nasa p orbital. Dapat, no? Although alam naman natin ngayon na hindi na. No? So 8 times 5, 40. Available. So for xenon, that's 8. 8 kasi group 8 siya. Fluorine is 7 times 4. 7, 14, 21, 28, 8, 36. 40 minus 36. 4 bonds. 4 electrons or 2 bonds. Ito yung problema. Hindi ko na itutuloy yan na. So look na. If I will connect my fluorines, dalawa lang yung pwede. So may malulungkot na dalawa. So palyado yung aking NASU rule. So that's okay. You proceed with the technique na. Yung technique. Ayan. Basta yan na. So ano yung technique natin? Count valence electrons. Okay, so kopyahin mo na lang yun nasa available. 36 na. Okay, so ito na yung remedyo natin. So 36 electrons. Then ano susunod kong gagawin? I will connect my terminal atoms to my central atoms using single bonds. No? 1, 2, 3, 4. So ilan na gamit ko? 8 electrons. Minus 8. 28, no? 28 yung difference. So lahat ng 28 na yan, I will use them as lone pair. So ilang lone pair yan? 14 lone pairs na. Then what will happen is that I will distribute the 14 lone pairs to my terminal atoms first. No? Pag may sumobra, central atom. Okay? So fluorine here, again, yung fluorine, tatlong lone pairs yan. No? Pag isang bond yan. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. May sobra akong dalawa. So sa central na yan, 13, 14. So yun, so what can we see is that the central atom, xenon, is bonded to 4 atoms and it contains 2 lone pairs. No? And this molecule exists. No? So yan yung tsura niya. No? So that's the summary. That's the end of the violations ng octet rule. No? So yan na yun. Tapos na yan. No? So sir, paano uli malalaman yung mga violation natin? Teka lang, urong ko lang to. So send ko to after the class na. Send ko dito sa GC natin. Para may reference kayo. Okay, so ano uli yung mga violations ng octet rule natin? Tatlo lang yan. We have the incomplete octet, the odd electron, and the expanded octet. No? Okay, so tignan natin. No? Incomplete octet. Ano meron doon? if your atom only contains s orbital or yung central atom ay metallic property siya, no? So, pwede siyang maging metal or metalloids. So, incomplete octet yan. Ano yung lunas, no? The remedy there is to just draw the Lewis dot symbol. Ayan yon. Tigi isang dot per valence electrons. Then you connect the single bonds. You connect the single dots to form single bonds. No? So, yun yung remedy dyan. No? The second one would be the odd electron molecules, especially for nitrogen-containing molecules. No? So, gamit ka ng NASA rule. Pag nakita nyo, add yung shared electrons. That means one of those electron is the A radical. No? Yung isa dyan radical. So, you continue doing NASA rule, then yung radical, ilalagay mo na lang siya kay nitrogen at the end. No? So, lagay mo na lang sa nitrogen. The third violation would be the expanded octet. No? So, kailan magkakaroon ng violation na ganyan? If your central atom contains D or F orbital. No? So, yun. The D and the F orbital can hold extra electrons. No? Yung D, kaya niya mag-accommodate ng 10 more. Yung F, pwede siya mag-accommodate ng 14 pa. No? So, ang dami niyang bulsa for the electron. No? So, how will you draw the structures? No? First, mag-NASA rule ka muna. No? Kasi baka malay mo, gumana yung octet. No? Pero pag pumali yung NASA rule, you use our technique. No? So, yan. For example, NASA rule failed here kasi 4 bonds lang, 6 yung kailangan. So, technique. You count the valence electrons. And you count the valence electrons, then you connect your terminal atoms to the central using single bonds. Then, subtract mo yung electrons na ginamit dyan. So, minus 12. Then, yung natira, lone pair yun. Distribute mo lahat na. So, ganun lang siya ka-easy na. So, again, just follow the NASA rule para ma-check nyo, ma-confirm nyo na hindi talaga siya sumusunod dyan. No? Kasi sometimes they follow, sometimes they do not. Ayan, so yan. Ayan, so ganun, count the valence electrons, connect the terminal using single bonds, then all the remaining electrons will be used as lone pairs. No? Okay, so we're almost done. No? Punta na tayo sa last part ng ating discussion. By the way, do you have any questions or clarifications or yan? Just if ever lang, no, just message dyan sa meeting chat natin or raise your hand. No? Pero if okay pa naman, I will continue na. So, ko-continue ako. Molecular geometry. So, may website ako dito na nakita. Ang cute ng website eh. Tingnan nyo. Ching! Diba? Ang cute. Okay, so ito yung website. Message ko nga dyan sa inyo. Para kung nasa laptop kayo, you can also open it. No? Message ko lang. Ayan. So if you are on your laptop, no, ayan, you can open the link. Pag nasa cellphone naman, after class, pwede nyo paglaruan to, no. Okay, so our last topic would be on molecular geometry, no. Molecular geometry. Okay, bakit natin kailangan to i-discuss? Because we live in a 3D world, no. 3D yung mundo natin. The fourth dimension would be time, pero hindi natin madodrawing yung time, no. Yan, but the idea is that we live in a 3D world. No? That means our molecules should also be in 3D. Because if our molecules are not in 3D, that means yung tao, dapat parang paper lang yan, flat yan. No? But hindi ganun. No? 3D tayo, no? May curves tayo, may shapes. No? So, 3 dimension nga. No? So that means our molecules should also exist in 3 dimensions. 3 dimensions yan. Meaning, hindi lang siya flat. Itong SF6, hindi yan flat na ganyan lang. Kundi, may certain angles yan. Itong XCF4, may certain angles din yan. No? Hindi yan isang flat lang. No? Okay. So, the question there is bakit? No? The answer would be this theory, the valence shell electron pair repulsion, or VSEPR, or I call it VESPR. No? Although Visepar yung basa dyan ng iba, ako Vesper na lang para mabilis, no? So, yung kwento ng Vesper, no? Ito kasi, our electron groups, no? When I say electron groups, it could be lone pair or atoms. No? Remember yung atoms natin, they still contain electrons outside the shell, di ba? Okay. So those electrons kasi, when they are near to each other, there is a repulsion. Kaya nga repulsion yung nakalagay dyan, di ba? Bakit may repulsion? Because remember, electrons are negatively charged. No? Negative sila eh. So, if they come into contact, yung negative at negative, magre-repel yun. Di ba? Parang yung magnet um, ni Thomson, di ba? So, yan, pag pinagdikit mo yung dalawang negative, magre-repel sila. So, that means, our atoms, yung lone pairs din natin, they will assume certain angles in order to minimize the repulsion. For example, itong dalawang atom, pagdikitin ko, remember na may electrons yung atoms na yan, di ba? So, pag pinagdikit ko yan, magre-repel sila, then they will split into certain angles, na? Pagdikitin ko uli yan, ayaw talaga nila, no? Bakit ayaw nila? Because they want to minimize the repulsion, no? As they minimize that repulsion, may angles silang na-form or may geometry silang na-form, no? Teka lang, yung pusa lalabas. Ayun. So anyway, so yun, lumabas na siya. So ano yung idea, no? Our atoms or the lone pairs, they can have repulsions, no? Pag magkadikit sila. So the remedy would be maghiwalay sila into certain angles, hence producing different geometries, no? So if our atom, if this is our central atom, it contains two electron groups, no? May dalawang groups outside. Then the geometry is linear, no? By the way, nandito 'yon, no? So download nyo na lang 'to. Question, sir, kailangan ba namin 'to kabisaduhin? Wag nyo kabisaduhin. May technique akong ibibigay mamaya. Pero kung kabisado nyo na, di okay, wala na tayong magagawa doon. Pero, again, ako, even in class, even in face-to-face class, index card, no? Para may cheat sheet kayo, no? Cue cards, no? So, yun. So, sometimes, hindi mo naman kailangan talaga magkabisado ng mga bagay, no? So, yun. Just save your brain space for better concepts, no? Okay. Pero for now, in our case, you may want to remember all of this, pero sa ngayon, kahit wag na muna, no? Pwede mo siya kabisaduhin, though may technique nga akong ibibigay mamaya, no? So, anyway, so ito. So, ito yung first ganap natin, no? So, this is our central atom, the purple one, no? So, if it contains two electron groups, no? So, the best angle or the best distance of these two atoms would be at 180 degrees, no? Angle, no? So, if they are separated at 180 degrees, anong shape yan? Linear, no? So, isang line lang yan, no? So, magiging linear yan, no? If our atom contains three terminal atoms, if the central atom contains three terminal atoms, the best separation angle would be 120 each, no? And naka-flat yan, no? Para yung paper na flat. Okay. So, yan. So, para siyang flat na paper. So, kaya ang tawag dyan ay trigonal planar. Triangle yan. Ayan yung triangle. Pero, flat yan, no? So, what's the angle for trigonal planar? 120 degrees. Pag dinikit mo yung isa, uurong yung iba. No? So, yan yung best angle. Ang cute-cute. Gigil eh, no? So, yan yung ganap na. So, that's the best separation angle. So, if you have three electron groups, your shape would be trigonal planar. Paano kapag apat? Ito na yung 3D. Pag apat, you will have a shape of tetrahedral wherein your bonds are all separated at 109.5 degrees. No? So, yan yung separation nila. 109.5 at all angles. No? So this bond and this bond is separated by 109.5. Ito at ito, 109.5. Ito at ito yung 109.5. Ayun pa yun. Yun. Basta lahat, they are all separated in 109.5 degrees. No? And the shape is tetrahedron. No? So, paano yung tetrahedron? No? So, tetra meaning apat, hedron faces. No? So, ano yung faces dyan? Drawing ko muna dito. Although may drawing na dyan sa handouts. No? This is your central. This would be your terminals. Terminal, no? Ito yung 3D way, no? So, ayan, may triangle ka dyan. Tapos may triangle ka dyan. So, apat yung faces mo. This part, ito, tapos yung nasa likod, then yung nasa baba. Apat na triangles. So, tetrahedron, no? Okay, so, yan. Ito naman siya, no? Ayan. Naka-drawing na dyan. So, better na may download kayo na ito, no? So, ito yung apat na faces. 1, 2, 3 sa likod, tapos yung pang-apat na sa baba, no? So, paano mo ito-drawing yan? Para yung microphone stand, no? Yung nasa baba, ito yung stand ng microphone. Yung nasa taas, ito yung maghahawak sa microphone, no? So, para siyang microphone stand pag drawing. Okay. So, that is if you have 4 electron groups, no? Meaning may atoms dyan na apat or may apat na lone pair, ganyan yung magiging shape na. Okay. So, paano kung 5? Ito, violation na to sa octet, no? So, pag 5 na yan, look, no? You have 3 atoms on this axis. Sa equator, may 3 atoms. Then, may 2 sa top and bottom, no? So you have 3 atoms in your axis. And yung atoms na yun, tignan natin, and yung atoms na yun, they are all separated by 128 degree angle, no? Tapos, yun, perpendicular siya with the 3 axial atoms, no? So, yan. So, yung equator, may 3 atoms. Naka 120 degrees sila. So, meaning noon may triangle dyan sa gitna. Then, yung axial, meaning noon yung from top to bottom, naka 90 degrees sila na separation, no? So, ano shape daw niyan? Ang shape niyan ay trigonal bipyramidal, no? So, asan yung trigonal bipyramidal dyan, no? So, this is the base of your pyramid, no? Your triangle. So, you can form 2 pyramids here. 2 trigonal pyramidals, no? So, ito yung una. Ito yung pangalawa sa baba, no? Drawing natin, no? I have 3 sa gitna, no? Sir, ano meaning ng dash and ano na yun? Yung may dash pati yung wedge. Meaning nun, yun yung 3D 3D positions, no? Pag ganito, ang tawag dito ay wedge, itong makapal. That means that bond is pointing to you. Nakaturo yan sa'yo, no? Pag ganito naman, yung Wi-Fi symbol, wedge yan. Meaning yan, the bond is pointing away from you, no? So, asan yung equator triangle natin? Ito yung equator triangle, no? Then, asan yung dalawang pyramids? Kasi bipyramidal eh. So, trigonal bipyramidal. So, this would be the first pyramid. Ayan. So, ayan, the first trigonal pyramidal. The second pyramid would be here sa baba, no? Ayan. So, another pyramid, no? So, we have 2 trigonal pyramids. Bakit trigonal pyramid? Kasi the base is triangle, no? Ayan. So, we have 2 trigonal pyramids or trigonal bipyramidal, no? So, yan. So, that happens when you have 5 electron groups, no? Ang pinapakita ko lang muna ngayon, tapos mamaya, mag-shortcut na tayo. Kasi ako, gumagamit ako ng shortcuts, no? Okay, and last one, if we have 6 electron groups, no, hanggang 6 lang pwede, no? So, if we have 6 electron groups, all the atoms will be located on 90 degrees, no? 90 degree positions, no? So, anong shape yan? So, sa equator, ito yung equator natin, makikita nyo, may 4 na atom sa equator. So, pag tigna 90 degrees ng separation yan, ang shape na mabubuo nila ay square. Yan o, square. Square. Okay, so square yan. So, may 4 sa equator. Then, may tig-isa sa top and bottom. So, anong shape daw yan? Octahedral or square bipyramidal. No? So, draw natin. So, this is your central atom. Then, I have 4 equator atoms. 2 nasa harap ko. Yung 2 nasa likod. So, ito yung shape na square. Yung isa nasa taas, yung isa nasa baba. No? Ang haba naman. Teka lang. Yung isa nasa taas, yung isa nasa baba. No? So, square pyramidal yung magagawa natin dito. Square pyramid. Ayan. So, meron din sa baba na square pyramid. No? So, ayan. So, square bipyramidal yan. Bakit square bipyramidal? 2 square pyramid eh. Kaya may bi na 2. Or, ang isang tawag pa dito ay octahedral. No? Paano naging octahedral? May 8 faces yung ating shape. No? When you say 8 faces, may 4 sa harap. 1, 2, 3, 4. May 4 sa taas. May 4 din sa baba. 1, 2, 3, 4. So, 8 yun in total. So, yun yung octahedral. No? So, yan. Or you can use the website. No? This website is useful para mas makita niya. Okay. So those are the basic electron groups. No? 6 yung electron groups and pwede tayong magka-form ng different shapes. No? So andito naman yung lahat. So kaya as much as possible, familiarization na lang. Wag na magkabisado. No? So yun, pag 2 yung electron groups natin, we will have a linear geometry. If we have 3 electron groups, we will have a trigonal planar geometry. If we have 4 electron groups, we will have tetrahedral geometry. If we have 5 electron groups, we have trigonal bipyramidal geometry. If we have 6 electron groups, we will have octahedral geometry. So yan, ano na lang, for familiarization na lang ng shapes na. Okay, so ngayon, ang goal naman natin ngayon is, di ba, sometimes our central atom can have lone pairs, no? So if the central atom possesses lone pair, magbabago yung shape ng molecule natin, no? So let's start with the first, atom na may isang lone pair. Kunwari, we have a trigonal trigonal planar yan, di ba? If this part, if itong atom, gagawin ko yung lone pair, what will be the shape now? Tignan nyo. Pag yan ay magiging lone pair, kakalimutan ko yung lone pair. So, tatakpan ko yung lone pair. Tinatakpan ko ng kamay, hindi nyo naman pala nakikita kamay ko. So, tatakpan ko yung lone pair na yan. Anong magiging shape ko? Magiging bent, di ba? So, yun. If yung trigonal planar, yung isa doon, pinalitan mo ng lone pair, magiging bent yung kanyang geometry. Hindi na siya trigonal planar. Bent na siya. Okay? So, whenever your central atom contains one lone pair, then yan, bent yung kanyang geometry. So, sir, ano yung sinasabi mong technique dyan? Ganito, pwede tayo gumamit ng codes, no? When I say codes, ito yung mga shortcuts. No? Paano yung shortcut ko dyan? I name the central atom as A. No? A, letter A. I name the terminal atoms as B. And I name the lone pairs as C. Ito yung technique. No? Ano yung magagawa mong code dito? So you have one central atom, so A. You have 2 terminal, so B2 yon. And you have 1 lone pair, E. So A, B2, E. A, B2E. So, tingin ka dito. Asan yung A, B2E? Ayan, A, B2E, bent. Di ba? Speed lang, di ba? Ayan, A, B2E, bent, no? So, ganun lang kabilis na. Sir, paano kapag walang E? Eh di AB3 yon. Pag AB3, hanapin mo na lang dito yung 3. Ayan, AB3, trigonal planar. AB2E, meaning nun, you have your central atom, and then you have your two terminal atoms and one lone pair. No? AB2E. Diba? Bent na yon. Na? Okay, so ganun yung quickest way para mas maging familiar kayo lalo. No? Okay. So yan yung first type na molecule natin wherein we change the atom as lone pair, no? Okay. So next one would be the tetrahedral, no? So we have this tetrahedral. Ayan yung tetrahedral natin. What if yung isang atom dyan palitan ko ng lone pair? Ano yung magiging code ko dyan? Tignan nyo. My code would be A, B3E. A, tatlong B, isang E. So what is the shape kapag AB3E? Trigonal pyramidal, no? So tingin tayo dito. AB3E. So AB3E, trigonal pyramidal, no? So one example would be ammonia. So paano mo i-drawing yan? So yung ammonia, di ba ganyan yan pag nag-Lewis structure kayo, no? Pag nag-Nasorul kayo. So para maging ano yan, since AB3E yan, this is your A, this is your B, tatlong B yan. As you have your E, no? Lone pair sa central atom. Then it should be in shape na trigonal pyramidal, no? Paano yun, sir, no? Gagawin nyo, your central atom, no? Yung terminal atoms naka-point pababa, no? Ay, ba't B? H pala. Yung naka-point pababa yung H, no? Para siya yung base ng microphone. Then yung lone pair nasa taas, no? So yan, trigonal pyramidal na yung shape na yun, no? This is the trigonal. Then ito yung pyramid, no? Yun, no? Kailangan medyo 3D kayo mag-isip, no? Kailangan nakikita nyo yung mga shapes, no? Okay, so yeah. So that's my first lone pair substitution, no? Pinalitan ko ng lone pair yung isang atom. What if dalawa yung papalitan ko? Dalawang lone pairs yan. Ano yung magiging shape niya? Bent, no? Magiging bent na siya. Okay, so magiging bent na yan, no? So, ano yung code ko dyan? A, B2, E2. A, dalawang B, dalawang E. A, B2, E2. So, tingin kayo dito. A, B2, E2. And A, B2, E2, bent. No? So, one example is water. When you draw the Lewis structure of water, ganito yan. So, yan. You have your A, dalawang B, and dalawang E. So, A, B2, E2. Anong pwede ko gawin dito? Ayun, isi-shape ko siya as bent, no? Wherein the central atom, yung terminal naka-bend, and yung lone pair, parehas nasa taas, no? So, ito yung bent, no? Yan. Yan, so may shortcut na tayo. May mga techniques na tayong makukuha, no? Okay, so hanggang dyan lang naman yan, no? Punta naman tayo sa 5 electron groups. Okay, so pag 5 electron groups yan, lahat atom, ang shape ay trigonal bipyramidal. What if yung isa papalitan ko ng lone pair? Anong shape yan? Sabi dyan, siso. Sir, paano naging siso yan? Ito, imagination lang ha. Teka lang. Ito yung stand ng siso. Tapos ito yung dalawang tao sa siso. Ayan na. Diba, saya-saya. Ayan. Ayan. Uy, halo. Nangyari. So, yan, nagsisiso sila. No? Gumaganon-ganon sila sa siso. Okay? So, yan. Bakit siso? Ayan, no? Imagine niyo na lang na ganyan, no? Ito yung dalawang tao nagsisiso. Okay? So, yan yung geometry niya. Siso. Okay. So, anong code ko dyan? My code would be AB4E, no? Paano naging AB4E? Central atom, A. We have 4B, apat na terminal atom. So, AB4, then 1 lone pair E. So, tingin kayo dito. Asa na yun? Ito. AB4E. So, tingin kayo. Ayan. AB4E. The shape would be seesaw. Ayan. Or distorted tetrahedron. Seesaw na lang. No? So, ganun. So, whenever you have 5 electron groups, pero yung isa doon ay lone pair, ay, ang shape niya ay seesaw. No? So, mas maganda gumawa na lang ng code para mas makabisado. Okay, so tapos na tayo with the seesaw. Kit. No? Okay, so palitan natin yung isa ng lone pair pa. Anong shape yan? Pag pinalitan natin ng lone pair, magiging letter T. Di ba? Ano letter T? So, assert your dominance. T-shape. No? So, yan. So, ano yung code natin dyan? A, B3, E2. A, tatlong B, dalawang E. No? So, tingin kayo dito, A, B3, E2. Yan, A, B3, E2, T-shape. No? Okay, so, letter T yung molecule natin. Then, pwede pa natin palitan yung isang electron group ng lone pair na naman. So, anong shape yan? Kung pinalitan natin yung electron group ng isa pang lone pair, we will have linear. No? Magiging straight line na lang yung atoms natin. No? Okay. So, ano yung code natin dyan? A, B2, E3. A, dalawang B, tatlong E. A, B2, E3. Tingin kayo dito. A, B2, E3. Ayan. Linear. No? So, ganun lang. Next one, we will have the, ayan, no? So, the 6 electron group, no? Or the octahedral. If yung isa dyan, papalitan ko ng lone pair, anong shape yan? Para ma-imagine nyo, yung lone pair lalagay ko sa baba. Anong shape yan? You have a square here. You have a vertex. So, parang square pyramid, diba? So, yun. Square pyramidal yun, no? So, if yung isa pinalitan mo ng lone pair, you will have square pyramidal. Ayan. No? Square pyramidal. Ano yung code natin dyan? A, B5, E. A, tatlong terminal, limang terminal, tapos isang lone pair. A, B5, E. So, tingin kayo dito sa table. A, B5, E. Ayan. So, ito, A, B5, E, ang shape ay square pyramidal or square pyramid. No? So, yan. Then, last one. More on memorization to, no? Kaya medyo matagal yung time frame.